All right. Let's see. Close that bad boy. Dun-dun-dun. Okay, that's our first slide. And that QR will take you to my GitHub that has all this in it, the slides and the stuff. So all I ask is that you don't play the audio before I do, because the files are all there, at the GitHub link. So, dun-dun-dun. Oh yeah, so welcome to the talk about music. Opposite of how to optimize your server for the best performance or whatever. This is, fun as opposed to all that. Well, that's fun too. So anyway, on with being nervous. Okay, so what this is about. What is it about? It's about writing files, MIDI files. It's the real-time stuff is next talk, and just a little bit of it. But this is about constructing MIDI files that you can play later or, right away after you make them, which I do in this. It's also about high-level object-oriented programming. It's, in my mind, it's like Legos. And so this is also about good old procedural algorithms. It's not about any AI magic that is used to statistically glom things together. No, it's about, for me, I made this stuff knowing about Western music theory. So a lot of this is divided into chunks that are like I say, Legos that you can snap together, as opposed to knowing all the parameters of MIDI, that's the next slide. What this is not about is analysis of other songs. Like there are modules, one that I even wrote that you give it a MIDI file and it'll tell you statistically this and that. Well, okay, so this is also not about real-time processing. That's next talk, which is immediately after this. So this is not like low-level MIDI events like I was talking about just a second ago. I got ahead of myself. Sysx messages and node on or node off. There are people that know all the parameters and fill those event link lists up and give that to MIDI and it plays it and it's cool. But I think in terms in a more high level. And so, this is not about AI. I just said that. And it's not about kittens. So as with last time, I'm sorry. So, yeah. So why make it anyway? So there's the creation factor, just that's exciting to some people like myself. And to make fragments for a larger context, like if you have a grand symphony that you're working on or a game, for instance, you can have bits and pieces like this is the monster sound, da, 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 this is the happy, da, 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 and then you could play those at different arrangements. So satisfy curiosity, like what does this beat sound against that beat? 5/4 versus 7/4. For practice and study, which is what I use it for a lot. I build little musical things instead of just a metronome, tick, 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 tick. I can have a beat, or I can have like chords that I can play, try to play solos on top of. So it's just better than a straight old metronome. So fundamental questions that we have to ask ourselves if we're going to make this kind of algorithmic music, which is based on theory. It's like expresses a theory. Also, it's exciting to me in that when I write something, I think this is like a smaller version, a subset of the wider music theory that there is about how stuff works and what's it sound like. So it's curiosity built in. So how do we construct a rhythm? That's the first thing I did when on CPAN was made a module for drums. So how do you generate pleasing harmony, which is related to the second part, melody. Melody is like usually a single note line that goes over the context of the harmony that's the chords. So how do you structure a tune? Usually there's a beginning, a middle, and an end. It's not just one long thing, but there are, it's controversial, the idea of development of a theme. Like, for instance, the music of Brian Eno, he has tape loops going in and out and things like that. He has different stuff going on that aren't, that are not based on traditional structure. There's guitar players that just wail and who knows what that structure. Anyway, so this talk, there are all these modules and more that may have gotten cut off on the bottom. Anyway, the ones in blue are the ones I'm going to talk about. But there are these music modules that they're more than this on there, but this is just ones that are made for creating music. So drummer stuff and chord progressions and things like that. All right, so here we get to the algorithms finally. So the basic formula that I figured out over the years of trying to at first I didn't know what I was doing, but now I figured out setup, sync, and write. First you set up your variables, whatever you got, then you sync them all together as a phrase, as a collection of phrases, which MIDI, the MIDI module provides the sync method, and you just hand it a bunch of subroutines that say, here's a note, here's a rest, here's a note, here's a note. So anyway, that's what I've done with bass and treble there, which I'll show on the next slide, what those subroutines are. And then we just write it to a file. So next slide, bass and treble. And in this case, we're just giving it static notes. We're not doing anything fancy, which is still algorithmic. I mean, it's still in a for loop. So, it's kind of half and half, but so let's see what it sounds like. But I look at my screen. Oh yeah. Oh yeah. Yeah.
That's not what his metronome said.
That's not what?
What Beethoven.
I know. In my last talk, I said with apologies to Beethoven because it's like clunky, but Beethoven was subtle. To this day. Okay, so that was the basics before: setup, sync, and write. And this uses the same formula, but it just sets up more stuff. Imports new modules, or a new module, the scale module, but it does the same thing: syncs bass and treble, and then writes it to a file. It's also a little faster, as the BPM shows you there, the beats per minute. So the bass algorithm is this, and first thing we do off the bat is set it to fretless bass. That just happens to be 35, and then we give it some pitches based on the scale module that we just imported. And then this algorithm, this for loop down here is basically the same as before, except we're getting our pitch by grabbing it randomly from the list of pitches that we have just set up. So there's the treble, which is the same thing, except it's got two octaves that it gives it instead of one for the bass, and they're higher octaves, 4 and 5. I'll give all these variable names and stuff, but some are variables, some are like static literal. So anyway, and then the algorithm is the same once again, but in the case of the bass, we get half notes. And in the case of the treble, we get quarter notes. So it's a little faster. So let's hear it. Pretty, it's random, the algorithm's on the. So I built in the previous slide, there's some way that it does a little pause. It goes da 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 and then pauses. Now I should have looked at my slides to figure out how I did that again. But anyway, it's not tricky. It's just the way that it worked out because I gave it quarter notes against half notes. So that's another cool thing about musical phrasing in general is that you can like juxtapose 2s and 3s and they'll sound good together. They'll just meet up after 6 beats or whatever, and then 12 and so anyway, here we go. The next set of algorithms is to play a list of chords. So we do the same thing: setup, sync, and write. I've called it chords and treble instead of treble and bass because we're going to show some new subroutines next. But new module is the chord note module, which helps us make chords. So these are the chords. We get ourselves a new chord instance because it's an object-oriented module. Then we give it a for loop of these static chords. So, and then the MIDI format is actually crucial because we have to change it from pound symbols and B's for flats into S and F for MIDI, the MIDI module, in order for it to know what you're doing to play it. So, so this chord module takes a chord name and turns it into a bunch of notes. So I just give it this list of chords on the 4 line. So we'll hear what those sound like, or what that sounds like. These are static chords, but it's kind of jazzy. Let's look at those. Whoops. Okay, sure. That's the chords again. All right. So anyway, so what if we match the first and the second together, or whatever the numbering was? So the random melody in quotes, with those chords. Let's see what happens. Okay, that was okay. Anyway, that's let me kind of back up and say this is there are a few kinds of styles of algorithmic music that you can make, and in the next talk I talk about them, but that's like choosing notes out of the air from random selection, and then next talk I'll talk about choosing rhythms out of the air. So here's the end of my talk. The links that are to where the talk lives, and I have a wiki that is how to make algorithmic stuff. Just all different kinds of things, junk drawer of things. So anyway, that's my talk. Are there any questions? Yeah.
Can you tell me where to find that fastest slide again?
Oh yeah, that's so the easy. I'm sorry. Oh, where can you find the slides for my tutorial? It's yeah. So just go to my GitHub account. Yeah, my name is Ology.
Thank you.
So just GitHub Ology will find me, and then it's a link pinned to my front page. I'm sorry for not having a link to it, like obviously big. So anyway, are there any questions? Also, yeah, Alex.
So the soloing there, I heard, it mostly matched except for one note which was sour.
Yeah.
And I think it was sour because it didn't appear in the scale of either the chord you were in or the chord you were going to.
Yes, the chord. He's saying he noticed that there was a sour note that didn't seem to be in any of the chord I was in, the scale of it. And that's true. And it's because it's like often it's like a half note. The chord is playing some certain 3-4 notes, and then it's a half note on top of that. And it makes it like, where are we at? Kind of, it's like sour.
Yeah. So I thought that's something that would be interesting to add to this graph to say,
Don't.
pick a random note and let's make sure that it's in the scale we're currently in or the scale that we're going to. So
Yes.
it'll make sense within a beat or two.
So I actually have a module, a baseline module, and then I realized it doesn't have to be a baseline. You can give it a higher octave of a different note. I mean, a different instrument. And it's that thing. It's exactly that. I was like, well, how do I conform what the melody or what the notes to choose for the melody are based on the scale or the chord that we're in. So you give this one method. You just give it a chord name, and it returns the number of notes you want that are within that chord. So, in the next talk, I'm going to talk about voicing and phrasing, which that module isn't in there, but it uses those techniques.
Right?
Yes. Another question.
Is there, so I know basically nothing about this, right? But like I once upon a time, I did try to look into Lily Pond, right?
Lily Pond, yes.
And I guess what I'm wondering is there a way to like go back and forth between either Lily Pond or some other like open
Right.
source tech-based, whatever transcription thing, and MIDI? Can you go back and forth so that you could like hack together your own, because like really good like composition software is crazy expensive.
Yeah,
Like,
right. It's composition software. It's expensive. Yes. Yeah. The DAWs and things that you can get possibly. So, your question was, can it go back and forth between Lily Pond and MIDI? Well, there's another guy named, what now I've drawn a blank. His nickname is Thrig. You're out there, I know that. Jeremy, somebody, I think. Anyway, it's on, just type in Lily Pond in Meta CPAN and his modules will come up. And I believe that there are exactly those kind of tools. But don't quote me on that. Hopefully it's, I know he does a lot of Lily Pond stuff, so it's built into it. I'm not sure exactly what it does though, because he does a different style of, I use this music theory that I learned in music school, but he does it more like a mathematician or a computer person and knows the event lists that are going to happen and inserts and splices things into the event list. And they, make all kinds of craziness. It's interesting. It's different, I try to simulate Western stuff. So yes.
So then you probably are familiar with Milton Babbitt.
Yes.
And this struck me, how.
Milton Babbitt.
I can't hear what you're.
Oh,
Yeah. Milton Babbitt.
Babbitt is well, he was a composer, but he said the next note in anything should be the least expected.
Interesting. The least expected next. Yeah. Nobody plays Babbitt because of that. Because that's what I was saying at the beginning, that you think up a theory like part of a theory, like the next note is not going to be expected. So somehow you simulate that, and that's your little bit of theory that you're expressing with this program, the MIDI program. I like that.
Well, you're doing a random thing.
Well, in that case, yes, random, yes. So
What about key changes?
key changes.
Like,
Mhm.
you're in C major, say, and then which is also A minor, and you might want to go to F,
Right.
and modulate.
Modulate.
Yeah.
Right.
Does this allow you to do
Well,
that easily?
people that have all the time in music go from the major to the relative minor, so you
Yeah.
go from C down to A minor.
Right.
Because those two scales
Are the
have
same.
6 of the 8 notes in common, right?
I think they're the same.
Those two scale, A minor and C major. Yeah.
The seventh is different. Seventh and A minor to G sharp. That's
Well-
the difference in the key of C.
Well.
But anyway,
The tools are out there to.
Say like you're going from C to F or C to B flat, something.
Right, the modulation of the key.
Yeah.
So there are tools out there to build to let you build the music for yourself, but it's not going to just magically say, "Oh, the next chord is this." You have to tell it, like with the bassline module, you tell it what the next chord is, and it tries to choose a note in common. And so there's stuff like that.
Where you can say, I want to switch.
Well, what would you do when you switch? That you have to tell the program
Yeah,
that.
but- Okay.
I mean, when you switch or where you switch. Yeah.
If you have an existing song, you want to just change the whole key, the whole thing.
Yeah, there are a couple of modules on CPAN that have been around for a while that do.
That's change all the notes. There's no add this to.
Well, there are a couple of modules. Like I wrote one that does transformation in 2 different ways. There's a couple of other modules that mathematically just subtract 12 notes or add semitones, and to get a different key.
There's no MIDI command.
Not that I know of, but there might be. And that makes me think, well, why don't I do that to my transpose module? Why don't I make a function that, so thanks, man.
I think that was the ultimate question.
Yeah.
Do you have a command to do that?
Yeah. That's the next step, I guess. That's how it works. That's how open source works too. You hear a friend talking about, and Matthew, right? Yeah. You're a friend talking about something. You're like, wow, I could build that. I could stick that in here. Yeah. Right. Okay. So, I think we're out of time, but my next talk is in this room about music. So, what's the schedule? Okay.
Any questions?
Yeah. Any other questions?
So, just to fill 3 minutes here, not all. I took like 19 years ago. I took like a music theory for morons kind of class, right?
Right.
And
Music theory for morons. Yeah.
Yeah, and so I basically, I know music theory, right? But we worked through a little bit of Johann Fuchs's Gratisat Vernassen. Are you familiar with that?
I'm not familiar with that, but that piece.
So it's basically like so he presents essentially it is an algorithm for given a particular melody, I guess is the term. I don't know, a single line of music.
Yeah.
How would you make counterpoint on top of it?
How would you make counterpoint on top of? I've used this old Amiga tool called Bars and Pipes. It's like a MIDI DAW, digital audio workstation, and it had exactly that. You would hand it some chords or another melody line, and it would counterpoint to that.
Yeah.
It was great.
Like for him, at least, for Fuchs at least, there were very rigid
Yeah.
rules.
Right.
You could only pick certain notes, and then from those notes, only to certain other notes.
Yeah.
Or avoid tritones or
Bach did, lots of people did have formulas for their cantatas or whatever.
So I basically still owe my music professor years ago an idea I had, which was, oh gosh, this is just a decision tree, right?
Oh.
And some of them are going to run into dead ends where you can no longer satisfy the rules when you went this way, right?
Mhm.
But it would be fascinating to give it a piece of music to create the decision tree. Maybe I can actually finally do that now.
Yeah, there are the tools because Perl is just generic, and so you can definitely glue stuff together. It's made to, and all of the modules way back here on wherever. There we go. Like these modules just use common elements, just lists of. There are like 5 different common elements. Some use lists of numbers, for the pitch classes. And some use lists of notes, note names like A sharp. Some say AS for A sharp. Some say ADIS, the German, CIS and DIS for sharp and flat, something like that. Anyway, but they're all interchangeable. If you use a couple in conjunction, then you might have to have a third that's a mapping between the two. But anyway, it's all there, and that's fun to make a music analysis. You give it a MIDI file or whatever, and it churns through it and tells you, the most common notes, the loudest notes, the whatever, and then you can use that information for whatever else you want to do next. That's none of this Perl is really super fast, so you might as well build a big subroutine to have it calculate what should come next, and then just smash it together into a file. So the next talk has a little tiny bit on how to generate it on the fly in response to a live event. So, but that's it when? That's like a while from now, right? 2:00 or something?
It's in
Like-
9 minutes.
All right. Well, I'll give you guys all a break from my voice. How about that? So thanks for coming. Oh, yeah. Question.
What software do you use to play MIDI files?
What would I use to play MIDI files? Well, there are a couple things. Have you heard of VLC? VLC is a media player that does all kinds of things, including on everything but Windows, play MIDI files. And also on every Unix type system, which includes what I use is a program called Timidity, which is a command line, does all kinds of conversions, but including just playing straight out, which is what I did for these things, but converted them to MP3s so that because it was just easier. Anyway, but on Windows, you have to use the legacy media player or media player legacy, which Windows 11 seems to have cut out. They it's not on the list of options to install. If you go through the hoops in the settings under system options, it's not there anymore. But with Windows now, there's like Linux subsystem and stuff, so you can get the tools that are out there to play MIDI. And it's really easy. And Timidity is tiny. So does that answer your question? Cool.
It's all fault.
What?
What was the sound?
I'm like, what? On the microphone? Sound font. Well, there are a bunch of sound fonts, and they're big, right? Like 300 megabytes or whatever, because they're samples. Did you say what are sound fonts? Okay, yeah, they're just a bunch of samples that are assigned to a particular like note or patch or bank. There's like different banks and then patches within those banks, and there's ones that are just really nice pianos, and there are some that are just drums. But I like the generic ones that have just about every, piccolos or not piccolo, English horns and things like that, timpani or whatever, including ethnic percussion, So I like generic sound fonts, but they're out there. You can just, there's this one, I wish I would have known you had that question. There's this one site that you can go to that has a bunch of them. Thinking, how can I find it really quick? But did you have a question back there? Oh, you just said you. How would I what? Test it. Well, there's unit tests for these modules, and often they'll test that like a particular method returns the expected list of notes or chord names or numbers of intervals between notes or whatever it's testing. So there are unit tests, but they don't test like the music of it itself. Do I say that again? What? I never have a. It just a lot of the things just make a file, so it just makes sure there's a file that got created. But I should go through it and use an analysis module to go, is this really for real? Well, welcome to my talk once again. This one is about advanced, and here's the it's the same exact. It's kind of boring. I don't have any fancy, screenshots or whatever. But anyway, the QR code will take you to my GitHub that has all the files. And so you can like follow along, or you can go back to like, what was he saying again? And go back on the slides. But anyway, so the first part of this talk will be similar to the last part, what this is about, which is writing MIDI files, but it's also about a little bit responding to events. And again, high level object-oriented things, like to my mind, are like Legos. You say, I want this module and this module, and then you glue them together, you snap them together. So, and I talked about this last time too, automating, I don't want to touch that, automating theories about music. If you have an idea, what does it sound like when you just say, I'm going to play in 2 different keys at the same time? What does that sound like? Anyway, that's a theory, little bit of a theory. It's not the whole grand theory of everything, if I'm saying subset. And procedural algorithms, once again. It's not about song or audio analysis, this talk rather. There are modules for doing that. Artificial intelligence, it's not about that. Generative AI, it's about everything. It's about procedural, but it's not about kittens either. So, yeah. Sorry, once again. Yeah, not enough people do. Yeah, we need to fix that.
Maybe we can get together a lightning talk real quick.
Yeah. Just go to some website that has a bunch of kittens. All right, so fundamental questions. Once again, how do you construct a rhythm? How do you generate pleasing harmony? And this is for traditional music theory, not just anything goes. And so how do you create a melody, which is often a single line going along with the chords of the harmony? So I realize not everybody here is familiar with music theory. So these are just some basic terms. I'm trying to just talk around them a bit, but everybody knows what rhythm is. Boom, chuck, boom, boom, chuck. So, but harmony is maybe a term that's kind of nebulous because it's just the background, the figure and ground. So the figure is the melody and the background would be the harmony in a way. How do you structure a tune? So once again, it's like a beginning, middle, and end. Maybe there's an intro and a verse and a chorus and another verse and then a bridge and then an outro. There's, with music programming, you have to think about these things ahead of time. It's not just going to magically come up with a structure that makes any sense. So you have to say, this is the beginning and I'm going to play these certain phrases. So anyway, what are some techniques of algorithmic music? Musical grammars like, Damien Conway's initial parse rect descent module. You can create a grammar that's got a set of rules that says what to do. You can have constraints on those rules or constraints on anything like probability or randomness. And it looks like my randomness got cut off. Thus, random sequences can be created by choosing from a pool of possibilities. So like, pool of possibilities would be, for instance, in the phrasing generator that I use, you just hand it, you say, I want a quarter note or an eighth note or a 16th note or a dotted eighth note or, a whole note. These are music theory, terms, but they just mean for durations, for how long you want the note to last. And there's also rest, don't play a note, but rest this long. So techniques, more techniques, probability, similar to randomness, but you control what's random in some way, and you do it for different parts of the music. You don't have to do every part of your algorithmic music in one way. Then it'll sound stale and kind of monotonous. You want to break it up, and that's one hard part about music programming is that every time you want to make something new, it's like a geometric progression. It's like a more exponential progression. It's like the more complicated you want to make the music, the amount that you have to program to make that happen, it just goes up exponentially, it seems. You're like, oh, I need to bolt this on. I need to change that algorithm. There's a lot of refactoring when you think, oh, I just wanted to go tink, tink, tink in this one part. Got to, phrase everything in order to be able to stick something in the middle. Anyway, stochastic, similar to probabilities and randomness. Evolutionary is interesting, of course. What after mutate and then see what sounds better. So you have to have some method of choosing what sounds better. So I often will just listen to it and go, I like that, and then record it. Like drag it into my DAW, drag the MIDI file that it creates into my DAW, and then assign it better sounds. The real sounding trumpet or whatever, instead of a MIDI. So, okay, here we are finally to the algorithms. So this talk is the last talk was about just how to get some sound. This talk is about how to phrase it in different ways, in a couple different ways. So here we have the stuff from before, the dump it out, the MIDI util, which I use to do, it's like a junk drawer of things that are handy, like set up a score for myself, automatically has volume and BPM and everything, beats per minute. So I get a scale, but the crucial thing is music duration partition. That is the phrase generator. So as with the first, the basic formula is set up, sync, and write. So here's where I set up my things that I'm going to use. This is the first part. And then I set up some more. The scale itself, just one octave. 4 is the number of the octave. They go from 1 to 9 or 0 to 9, something like that. Anyway, I print out the pitches, and then I go through the loop that says for all the motifs that I've gotten, which are back here, the music duration partition is the object that has these pool of durations, half note, dotted quarter note, eighth note, and it makes some motifs, 4 of them. So then we use those, we go over those 4, and for each we find random pitches and add them to the score. So this, this makes a phrase with choosing from a pool and then choosing from a random pitch. So, and let's see what that sounds like. Here's what it looks like. This is what it sounds like. So it's not just, it's like, it's more pleasing phrases, rhythmic phrases. It's not just a metronome of steady phrases, steady notes. It's like da da da, da 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 da. So, but it's still random notes. So that's not the coolest. So how about some voicing? So my friend Jeremy Mates, whose nickname is Thrig, I said I couldn't remember his name before, but now that's his name. He wrote this cool module called Voice Gen, which is the new one in the list here. And I'm just going to use that to get notes as opposed to grab them randomly from a list. So once again, everything's the same, 4 motifs, rhythmic phrases. And then I get 2 octaves again for my pitches. But then I make a voice generator called voice. And then in the for each loop over the motifs, I use that. I just say, hey, voice, give me a random one. And what it does is you give it a list of allowed intervals, and it only chooses, notes that are so far away from each other. It won't choose the very first and the very last and the middle and then the last. And it chooses them in some kind of order that is, you specify, but can be close to each other. So, and again, that's the same pattern. Set it all up, which in this case was a bit, and then, sync and write. So this doesn't have the sync part. This just adds to the score. We have one score. So what does that sound like? It sounds more reasonable. But it's still random, it's still choosing notes out of the blue, but by according to a more ordered system. So here's another one just for kicks, because it's always different. So this is just generated from the computer directly. I had no hand in it. So it sounds kind of, Bach-ish. So let's see. Okay, my groove tool. This is a tool that I made to practice chords, piano, guitar, whatever, over a rhythm. That I made it actually to help generate combinatorial rhythm patterns based on this other module that I wrote based on a book. It produces primarily why I want to show it is makes a randomized figured bass line using these techniques, using phrases, motif phrases of rhythms, and then voicings, and it mashes them together in a bass line. So here's my groove tool. It's already up. And I've already got a piece loaded, a thing loaded, which is, I'm not going to explain the UI, but anyway, we'll generate that, and it makes us a MIDI file. So I can play along. All right, so let's try another one just for grins, just because we're here. Just click the generate button. This. All right, so here's the code behind that. It's giving us a phrase, but of 3 beats, and of the same pool of possible durations: a half note, a dotted quarter note, eighth note, and then I tell it some weights. Like if you're going to play an eighth note, also groups. If you're going to play an eighth note, play 2 of them, and like half or twice as possible to get one, because of the weight is also 2. The weights of the others are 1. So anyway, I'm just saying, if you have triplets, if you want to play groups of 3, you just say 3 in the groups. But I didn't. That's not for this. I wanted this to be a more metronome. Anyway, so we generate 2 groups, 2 motifs. Here's the voice generator, where we give it the allowed intervals. It's the same. It's no different. And the pitches from a scale. So then we generate voices, 1 set of voices over these, the first set of motifs, and there are 2 motifs. So on the second set of voices generated inside the for loop. We say, okay, we're going to add to the score, and the second time around, we want a different phrase. So it doesn't sound like completely monotonous, and it'll use the second motif always. So that's you have to think ahead of time what you want your music to sound like. Whereas if you pick up a guitar or sit down at the piano, you just play what you feel. So this is just kind of exactly opposite in a way. You have to, but you can do it without knowing any music theory. I just based my stuff on music theory that I know. And anyway, let's see what the next slide is. Okay, the application to games. So my friend John Barrett, he's a friend, an internet friend. He lives in like the UK somewhere, I believe. He wrote this really cool FFI module, foreign function interface, which I believe you gave a talk about earlier. Yeah, Graham. So we use time high res in order to use micro seconds for sleeping. So we built up a monster score by saying that we want these microseconds and then convert the score to events, which is a part of my utility, MIDI utility module of just handy events, get microseconds and score to events, which in this case are useful here because we need to get the list of events, which I was talking about earlier, that I don't manipulate directly, but they're there. And so this converts one to the other and we get a new device and it's for like Windows in this case. So, because it works in different ways on different systems. So Windows, you look for something, with wavetable in it. I mean, it's a full name. It's like GR wavetable audio or something. Anyway, so here's where we actually respond to an event in Monster in this case. So, this is all, it's not like, it's still, it's why it's last in my talk is it's under development. He's working on it and it's excellent. It works great. Like on my Mac, it works fine too. I can, pump stuff out with this for loop that says go over each event and count the microseconds and then send an event if we're done with a note on by seeing a note off. So anyway, it's like not as important to understand this algorithm as it is to say, this is what you have to do in order to get some real-time stuff. Because right now it's really low level. And so you kind of have to know what your events, what you want in your events, but you can create it in a score and convert it to a list of events. So it's not that complicated at all. I just wanted to show it because it's out there in the wild and it's a MIDI thing. It's made for real-time MIDI. So that's the end of my talk. And once again, here's some, links that take you to various places. And this slideshow is on GitHub. And once again, like the easiest way to get to GitHub for my stuff is to go to GitHub and Ology in Google. OLOGY is my know-it-all nickname, even though I don't know it all. So anyway, go there and there's links pinned to the front of the page of my GitHub. So are there any questions if we have any time?
5 minutes.
What, 5 minutes?
Question.
All right,
That's
okay.
what they say.
All right, well, I don't want to stomp on whoever's next, but 15 minutes till. Cool, all right. Are there any questions that you guys have? Yeah, Graham.
I'm just curious. What you said about games and stuff like that. I think LucasArts had something called
iMuse by LucasArts.
Yeah, LucasArts.
Yeah, I remember that company.
Really interesting game things.
Yeah.
And it would like synchronize the music depending on like what was going on. With
Uh-huh.
adventure games,
Yeah.
Star Wars things. And I'm just wondering if you've ever heard of that or.
Well, I have heard of it, and I just know it was a thing. But and this is not new. The MIDI responding to events in real time. It's not new at all. It's just newer to Perl because people have worked on it before but never got it entirely working for some reason. But it's just new to Perl in a way, in that he just with the FFI has created it. But yeah, I don't know if those could be ported. That could be discovered, pulled the C code pulled up and.
Yeah, I don't even know like exactly what the implementation it was, but just as a user, I felt it was very good
Seamless transitions are always the best. Question.
So if I had this really neat sort of miniature recreation of a Nintendo device,
Uh-huh.
that had nothing
Recreate.
to do with Perl, but I talked about it anyway,
Uh-huh.
then how could I use this as part of an interface or emulator
Mhm.
to handle at least the music part of that?
Well, for like Windows, it'll just play it automatically out of nowhere if you have this code, because it's the driver is just always there. That the wavetable is just, I don't know how it works, man. It's some kind of magical thing. When I tried it on Windows, it was like, oh, I don't even have to start a DAW. Like I was going to start Reaper, and there it was. So I was surprised. But with like the Mac, you have to have DAW like Logic Pro or GarageBand to.
And a DAW.
But so. I'm sorry, DAW is digital audio interface. It's just a music program that stitches all your tracks together, and you can have MIDI or audio. You can record your voice, but if you had a presentation, you could have, and it was like triggered from a Windows box. I'm just saying it could be automatically there. But for like Linux or Mac, you'd have to do some maybe have a program up that intercepts the signals and says, "Oh, you're a MIDI signal," and plays you. Does that answer your question? Maybe.
Cool.
All right.
Well, it gets me a step closer. To
I'd like to get real-time MIDI going on so I'm working on it. Like I was scrambling to make this couple of slides even better. So they're, not the prettiest, but